Hello everyone, and welcome to lesson 6.5 on interpreting y-intercepts and slope. In this section, we are going to talk about two of the three different versions or different ways to write a linear equation. Those two methods are called slope-intercept form and point-slope form. Each of these are important because in different kinds of problems we will be asked to solve for lines or write an equation of a line, but we're going to be given different pieces of information. So with slope-intercept form, we will be given the slope and we will be given the y-intercept. In point-slope form, we will either be given just 2 points or we will be given a point and a slope. So those two things are very key and critical in knowing which equation to use, how to solve equations, and how to move forward. So a couple new pieces of information for us with slope-intercept form is that we've already covered previously that slope is the steepness of a line, and that the variable we will use in equations to describe slope is the letter m. Y-intercept is the place where the line crosses the y-axis, and that point, our y-intercept, is going to be shown by the letter B. So anytime we see the letter B into a problem, we have our y-intercept. You can see in slope-intercept form, we have y equals mx plus b, and as we've talked about just recently, you have that our m is where our slope is, our b is where our y-intercept is. Now, let's take a quick second and talk about forms. I don't know if we've talked about this in any other lessons, but forms are basically outlines for equations. They're general formats. I like to call them cookie cutter shapes because cookie cutters only can give us the shape of a cookie. It can't decorate the cookie for us, right? So if you're on the holidays and you're trying to make cookies, maybe you can cut them into circles, or you can cut them into stars, or you can cut them into snowmen. But generally speaking, whenever you see a form or something called a general form, those are cookie cutter shapes. Those are outlines, just the bare basics. This is what slope-intercept form looks like. It's y equals mx plus b. Point-slope form is a little different. We can see that we still have that m in our problem, which does mean slope. But now we also have in there our x1 and our y1. And if we remember from our slope formula, x1, y1 is for organization purposes, and that represents the point that we are given. It tells us which x and which y to plug numbers into. Right? Nothing crazy there. It's for organizational purposes only. Now, on the next screen, we're going to look at two examples of slope-intercept form. We're also going to look at two examples of point-slope form, how to use the formulas, how to plug in numbers, and how to solve. So, let's start. So, examples 1 and 2 say, write an equation of a line with a slope of 1/4 and a y-intercept of -2. So, there's a couple key pieces of information here. One, they tell us that we have a slope of 1/4, and secondly, we have a y-intercept of -2. It's always important in these kind of word problems just to pull out your important pieces of information and just write them down so you have them. Well, a slope of 1/4 means that my m is going to be 1/4, and a y-intercept of -2 means that b is equal to -2. Right? So, let's just start. Since they've given us a slope and an intercept, we're going to use slope-intercept form. That's going to be y equals mx plus b. Well, we know that our slope is 1/4, so y equals 1/4 x, and we know that our intercept is -2. And all we really have to do there is just plug in the numbers, right? We knew that the slope of 1/4 gave us that 1/4. We know that the y-intercept of -2 gave us the -2 on the end, and we're done. There's not any more to it as long as we're using the right form and they give us that information. Okay, problem number 2. It says write an equation of a line with a slope of 3 and going through 2, -9. Okay, so let's look and see what they've given us. All right, first, they've said slope of 3. So that's good news for us. We know that our m is equal to 3. But the next piece of information they've given us is this point. So they've given us a point to -9. So in this case, since they've given us the slope, they've given us a point, we're going to use point slope form. Point slope form is y minus y sub 1 equals m times x minus x sub 1. And now what we need to do is we need to plug in our numbers. Just like we have in the past, right? We're going to label our point x1, y1. Now we know where to put everything. That's going to end up giving me y minus y sub 1, which is -9, equals m, so my slope is 3, times x minus x sub 1, which is 2. And we simplify that. That's going to give me y plus 9 equals 3 times x minus 2. And for this section, we do not need to go any further than that. Eventually, some of you watching this or looking at this problem will say that, oh, I can simplify that. There's distributive property I can do. I can subtract the 9. Like, yes, we can do all of those things. But given our state right now, this is what they're going to ask us to do, and this is what you're going to need to do. All right, moving on to examples 3 and 4. All right, number 3 says, write an equation in point slope form, f of -7 equals 5, and f of 3 equals -4. Well, the first piece of information that we need to look at is that it told us exactly what form to use. So, using point slope form means that I have to use y minus y sub 1 equals m times x minus x sub 1. All right. Now we're dealing with our function notation. Anytime we're dealing with function notation, we're dealing with points. They're just giving you points in different ways. So here's how to handle points that are given to you in function notation. If it's inside a parenthesis, that's going to be your x value. If it's what everything is equal to, that is your y value. Same thing over here. X value is the 3. Y value is the -4. I know it looks weird, and some of you are probably thinking, like, why don't they just give it to us the other way? It's so that they can test you on understanding different notations and how to get information from different notations. Again, once we have x and y, we just need to probably go ahead and label those x1, y1, x2, y2, and we're in good shape. So basically what we have here is we have one point that is -7 and 5. We have another point that is 3 and -4. We know that we have x1, y1, x2, y2, right? Just writing it a couple times in a couple different ways to help you guys out. But they didn't give us a slope. So I guess that means we're going to have to calculate slope on our own. So to calculate slope, we go back to our slope formula, which is y2 minus y1 over x2 minus x1. That's going to end up being equal to negative 4 minus 5 over 3 minus negative 7, which is equal to negative 4 minus 5 over 3 plus 7, which is equal to negative 9 over 10. All right, so now we got our slope is negative 9 over 10. Now that we have our slope, we also have a good point that we can use here. All we have to do is plug in that information. So, y minus y1, which is 5, equals our slope, which is negative 9 over 10, times x minus x sub 1, which is negative 7. And then we finish off by just simplifying those double negatives inside the problem. Y minus 5 equals negative 9 over 10, parentheses, x plus 7. And now you've written the equation of a line. That was a little more work than probably some of you were expecting. But here's the deal. Now that we've covered how to calculate slope, calculating slope for an equation is fair game, especially if you're given 2 points. Yes, we're dealing with these new forms of equations and using point-slope form and slope-intercept form. That doesn't exclude you from also having to calculate the slope on your own. They may not give it to you directly. So it's a big test. Okay, moving on to number 4. We have write an equation in slope-intercept form. So this problem again tells us exactly which form to use. Slope-intercept form is y equals mx plus b. Unfortunately, they did not give me a slope, and they did not give me a y-intercept. So it looks like we're going to have to calculate those on our own again and find those equations. So I'm going to just very quickly just move this form over here to give myself some room to work. And we got to go back and pull our points again, right? Remember, inside the parentheses is an x, outside is a y, inside the parentheses is an x, outside is a y. That gives us 2 points, 1 comma 2, and 3 comma negative 6. So then, solving that, we get x1, y1, x2, y2. We can use our slope formula, m equals y2 minus y1 over x2 minus x1. That's going to be equal to negative 6 minus 2 over 3 minus 1. That's going to be equal to negative 8 over negative 4. Negative 8 divided by negative 4 is positive 2. So now I've got my slope. Now to figure out our y-intercept, we have to do something a little different here. We are going to have to use, and we'll put this in a different color, our point. And we're going to have to use our point to plug in for x and y. The reason that we have to do that is because if I have an x, if I have a y, and if I have the slope, I have 3 of the 4 variables for my equation, and I can solve for the missing one. Let me show you what that looks like. If I'm using y equals mx plus b to solve the equation, and I know that y is going to be 2, I know that my slope is 2, and I know that my x value is 1, the only thing I'm missing is that b. To solve for b, I can do what we've done before. 2 equals 2 times 1, which is 2, plus b. And then I subtract 2 from both sides. And that ends up giving me that b is equal to 0. Solving for that has helped me to get what I need to know. So when I go to write my official equation, I have it as y equals 2x plus 0. I will say, as a final note with problem 4, once you solve for everything and plugged in everything, a lot of times if there is a plus 0 on the end, math textbooks, math worksheets, online programs, whatever, are not going to give you that plus 0. They are instead just going to write y equals 2x. So just be prepared for that. So, in this session, we've talked about the 2 new formats and how to plug numbers into those formats correctly. You have also seen that in some cases we have to calculate slope on our own. That might have been unexpected at the beginning, but it's stuff that we've done before. And so if you can calculate the slope on your own and use that to help you to either get missing pieces or fill out the entire form and plug in numbers in the right spots, we're going to be in good shape. Like I said, we're just worried about plugging things in. We're not worried about simplifying, especially with point slope form. So hopefully this has set you up for success in this section. But as always, if you have any other questions for me, please reach out to me and let me know.